Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 16, Atoms, Molecules, and Ions, Part 3. Here are our objectives for today's video. Pause here. So on the periodic table, as you can see, we've got rows, we've got columns. We're going to be most concerned with columns, so you wouldn't believe that I have to say this every year, but I have to say it every year. Columns go up and down, rows go left to right. So groups are the columns, the ones that go up to down. They have common properties because they have similar electron configurations. That's actually why I put chapter 7 before chapter 2, because I want for you to have some knowledge of electron configurations when we start talking about this. And then we have rows, which are called periods, which share quantum numbers, which won't really do all that much until we get to our covalent bonding chapter, which isn't until the end of the year. So for right now, we're really only concerned with groups, meaning up and down. Pause here. So before we get into the properties of the groups, we're just going to go through them and make sure that you know where they are. So when I say group 1, where are my tools to draw on here? Okay, interesting. I typically have tools. So this first column right here, so hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, these are called the alkali metals. Hydrogen's not a metal, but it's still a part of the group. Then we have group 2, so beryllium, magnesium, calcium, strontium, barium, radium. Those are our alkaline earth metals. Then we skip what we have been calling the D block. We're just going to skip them for the time being. Those are our transition metals. Then we're going to skip over to this whole group with boron. We're just going to call that the boron group. So boron, aluminum, gallium, indium, thallium. That's the boron group. Very creatively named. Then we've got carbon, silicon, germanium, tin, and lead. That is the carbon group. Nitrogen, phosphorus, arsenic, antimonium, bismuth. That's the nitrogen group. We have our oxygen group with oxygen, sulfur, selenium, tellurium, and polonium. And then we have our halogens. Our halogen means acid forming. So we have fluorine, chlorine, bromine, iodine, and astatine. And then you've probably heard of these are noble gases: helium, neon, argon, krypton, xenon, and radon. So these are the groups in the periodic table. So just make sure you know where they are. And then we're going to talk about the properties of a couple of these groups. Pause here. Right, so we learned last chapter, all of these have one valence electron and it is in an s orbital. All of these end in s1. So they really want to get rid of that electron and to have a noble gas configuration. So when they react with water, they will give water that electron, and it is such an exothermic reaction that it literally creates an explosion. You'll see fire and stuff. I've accidentally caused an explosion. If I haven't already told you that story, remind me in class, and I will. They form an alkaline or a basic solution when they react with water. And then these alkali metals, they're very soft. You can actually cut them with a spoon, and then they are silver in color, all of them. Pause here. Then we have our alkaline earth metals, our beryllium, magnesium, calcium, etc. These have 2 valence electrons, and it is exothermic to get rid of those 2 electrons to have a noble gas electron configuration, but it is not nearly as exothermic as with an alkali metal. It will react with water. You'll see some bubbles forming, but it's not explosive. And the product is also alkaline. Alkali, alkaline, it means the same thing, really, but for whatever reason, we call one group the alkali metals and the others the alkaline earth metals. Then we're going to skip over our transition metals: boron group, carbon group, nitrogen group, oxygen group, just because their properties are a little bit less cohesive. And we're going to skip over to the halogens. So all of these have 7 valence electrons. I'm not counting any D or F electrons because they don't tend to participate in covalent bonding. These can be solids, liquids, or gases, though many of them are gases, and they will react with water to form acids. So that's how we get our hydrofluoric acid or hydrochloric acid, hydrobromic acid, and hydroiodic acid. Astatine doesn't really do that, but the rest of them do. Pause here. And then we have our noble gases. All of these have complete valence shells, so all of their valence electrons are paired. And all of these are gases, and they are inert. So That does not mean that they can't react. It's just that there's not a energetic reason for them to react. So we are going to see cases where they do react, but it's just very uncommon. You're not really going to see it, say, if you like go and major in chemistry in college, you're not really going to be working with noble gases, but it doesn't mean that they can't react. It's just not super common. Pause here. So these are just our common charges, and I realize that my the software is blocking it, but our group A, that's our helium or neon, for example, and the common charge is 0. So we talked about this a little bit last chapter because of the uh, all of these noble gas or all of these elements want to get to noble gas electron configurations, and they're going to gain or lose electrons to get there. So group 1 is going to lose 1 electron to have a charge of +2. Group 2 will lose 2 electrons, have a charge of +2. The transition metals we will talk about later. We're just skipping them for right now. The aluminum group is going to lose up to 3, or no, it's going to lose 3 electrons, and not up to have a charge of +3. Our carbon group, our carbon group doesn't tend to form ions, so that's why the common charge is 0. Nitrogen group, it has 5 valence electrons, so it's going to gain 3 to get to 8, so it'll have a charge of -3. The oxygen group, they have 6 valence electrons, so they will gain 2 to get to 8, so they will have a -2 charge. The fluorine group will gain 1 to get to 8, so it'll have a charge of -1. And then you just won't, in general, see the noble gases forming any sort of ions. Pause here. And then we've got our sort of last section of the periodic table. These are actually a subset of the noble gas. Sorry, I just said noble gases. These are a subset of the transition metals. But at the bottom, we have our F block. The first row of the F block, these are our lanthanides. And then the ones below these are actinides. They are metals, so they've got all the standard properties of metals, but they also tend to have partially filled F subshells, which just makes them look really cool. Like if you see any of these in real life, some of these are shelf stable, some of these are not, but the ones that are, they look super pretty in real life. You'll see very interesting colors and things like that. All right, that is all for tonight. Thank you so much for watching and have a great night.